I'm back again. I was doing some tests earlier on, and I was trying to use the viewing film. Well, I deleted that video. But anyway, this one, I found another way of showing something. It's a little bit more visual actually, it's a little bit easier to see this. But with the north pole pointing towards the switch when it's activated, using my nail file, I should be able to see it bending when I lift it up. I don't know if the camera's low enough. Now there's null spots because the blotch wall is actually over here at this point here. This null spot is where the switched field is equally north and south. Because of that, there's actually no attraction at this point with the magnet's bias in it. And when I move towards the magnets, obviously it will start to stick. Now at this point it's null. Now if I get my pen, let's get a blue pen because I'm using north at the moment. So with my blue pen I'm going to put a little line there. That's the null spot with north. I can feel a little bit there, but a little bit over here. That's the null spot for north, right? Now I've drawn a line on this piece of pink felt, which I've put on here to stop me from crashing into it. Now I'll switch it round and I now I'll put south on that line. Now we find that this null spot is no longer in that. This where it was null before, it's no longer null there, because the field has moved, and the null spot is actually over here. So with south, the blotch wall has moved over here, right? You can see it sticking there. Not sticking there, look. It's sticking there, look. It's sticking all the way up to where the blue section was. So the null spot is actually right here for the south pole. So if I get my red pen, actually right about there. So with the south pole, the blotch wall has moved to that point. Actually it's a little bit, that's right, yeah. So you can see how the field switching and is influenced by these two magnets, with these two magnet pillars that are different poles. You can see how the actual switching is different. And that's interesting because that's exactly what's basically happening with the fields on the other end. Actually, there's more. The south is being pushed out. Sorry, the north is being pushed out more in this direction than the south would be. The south is actually in a different. Let's see. Now on the other end, we're biasing it south at the moment. Now there's very little on this end here. very little there. Just to demonstrate this with the magnets, this is exactly the spacing there would be in a cone on my rotors, because if you look at my rubber, which is what I used to space the rotor magnets from the actual actuators anyway, that's the equal amount of spacing there. So we're using the exact same spacing. Now this nail file, it should not really stick very well. It does stick a little bit though. There's a little bit of self coming through there, but not much. Very, very little. Can it hold this bigger thing? This nail clippers, can it hold that? No, it can't. As you can see, these nail clippers cannot be held up. There's just not enough field there to hold them. Now let's change the polarity, this is supposed to be more active for north. Now we're actually right on this line. Don't know if you can see the line. Yes, you can on the camera. Now I'm going to take this off and put north right on that line. Just to check that the rubber goes between it. Now can this hold this up? Yes, it can. So what we're seeing is this switch does work. It actually allows the north pole to be sent through, but not the south. The nail clippers are actually still being held up there. If I move these magnets now carefully, we should see it drop. There we go. I'll put them back. I need to get them back on that line. Now it will hold them again, because we have actually a lot of flux there, because this nail clipper thing's got a spring on them actually, and you can see I'm pushing the bottom part down and the top is still attached. So I'll just pull that out this way if I can, yeah, and sliding it off, and we have our deflection. Obviously there's a big gap there right at the moment, but that's the whole point. We don't want to oversaturate the switch, because then it would no longer be a switch. You would have we would have too much flux passing through. At the moment, when I'm touching this top part here, there's very little on the top. It's all coming out this end. So as you can see, I can lift the whole thing up, look. It's lifting the whole thing up, look. But not here. The file hardly even bends. There's nothing there on the north line, but there's a bit on the south line. Now turning these around again to south, can we lift up the whole thing like we did with the north? No, not a chance. We can't lift it up. There's nothing there, absolutely zilch. Something bigger, screwdriver, will that be attracted to it? No, nothing there. So we flick this around again to north. On that line. And now we easily pick the whole lot up, because there's a lot of switched field there now. So anyway, push it off with my finger because it's pretty strong, that. just thought I'd do another short video to show you that it does work. And I discovered earlier why I had an anomaly, and that was because there's a slight offset with these get this off. These little bars underneath, there's a slight offset. If you look, they're slightly offset to one side. It's important that on the switch, on the output side, we actually have a little bit more iron than we do on the actuated side. So there's a gap between these two pieces of metal here. A tiny gap, because the actual ends are rounded actually. So there's a slight curvature where the two pieces at the bottom come together. Then there's a solid piece of iron, a 20mm piece of iron across the top. It's like a step. So that's basically that. Now I'm just wondering, actually, I have got some different magnets somewhere. I'm just going to have a look, see if we can try something slightly bigger. If I can find them. I think they're actually in use somewhere. Well, actually I found 3. I'll see if I can find a 4th one. I've got 3 slightly bigger ones. These are N52s. They're tiny still, but they're still stronger. Let me see if I can find one more of those, because I would like to try it with something a little bit bigger. I think they're actually attached to my generator. So I'm going to have to take them off there. It's too warm to sleep, actually. I'll just get one. If I add it to these, I've got 4 now, so I should be able to put 2 slightly bigger ones on each of these. So let's see, I'll take 2 of these weaker ones off. Actually, I'll just remove the whole block and just we want 3, so I've got 2 of the bigger ones at the bottom and one tiny small one on the top, so that should give us more flux on the switch to see what effect that has. If I can get these apart. Not easy to. Right. Try not to break them. I just need to make sure I've got the polarity right. That should be north. South, yeah. If I stick that on there. Now let's put the bridge back on. See with this these lines are in different positions now. Oops. Right. Okay, I'm hoping I've got the gap the same. Let's put the rubber in. That's right. That's about the same. Now let's test. Oops. Let's see, is it south that's facing it? I've forgotten now. I can't remember. No, we've got north facing it right now. Let me check this gap again. That's right. Now, the question is the red line in the same place? No. It's actually moved over here, you see. And we actually have some pull on this. Hang on, have I got this right around? I can't remember now. Just a minute. Yeah, that's actually north pointing over here. So it's north that's pointing towards the... Get the gap right. We've got to do this so that it's an accurate measurement. Right, so it's north. So that's actually in the same place. The null point, the north is in the same place, and that's on, and that's right. We've got deflection on the gauge. So when I turn this around, will south be in the same place? Because we're actually using slightly more powerful magnets on the switch now, and I want to find this out obviously because it's important to know what changing the magnets on the switch would actually do to this configuration and how it would affect it. Now we've got south, so that should be null. Oh yeah. Actually, that red line has moved a fraction. We're talking about a millimetre. The red line is actually moved a bit over here, I think. And this end is off. There's a slight bit of pull, but we can't lift it up. I'll just get my I'll get the screwdriver again. You can see it won't lift. It won't lift that. So that's good because it means that the magnets themselves, as long as they're balanced and equal, won't do any harm. Now, what I am interested in though is when it's on, is it going to be stronger? So let's put the north back forwards. Check our gap. Is the north actually stronger with these other magnets? I think maybe. Let's just put this underneath and let's see. Well, it feels a bit stronger now. But we won't really know until I bring this really close to this because at that height before with the other magnets it was barely lifting it unless I put a bit of blue tack, which I done here. I was lifting it slightly, so let's see if we can easily lift this now. Oh yeah, that's a lot easier. Definitely lifts it a lot more when I bring it closer and watch. I haven't even touched that yet, and it's lifted it. Let's try it with this stack that I was using earlier. Oops, I lost one. Oops. Just want to get the polarity right. That's the right one. I'll just lift that now. I don't know. This is a smaller stack, obviously. No, the little stack can't really lift that unless it's slightly higher. When I helped it lifted then. But and it's pulling a bit on there. Unless it's biased totally off. Now it's totally off. It's a slight bit of pull on there. Oh, it's just barely pulling it, lifting the whole thing up. Just barely doing it. Unless I bias it off like that. Oops. I can't sleep tonight, it's too warm. That is pretty strong, that now. In fact, I'm almost afraid I'll break it. Oh well, that was worth testing out. Anyway, I'll save this video. So I guess that's it.